Hey everyone, this is the three-sum problem from LeetCode. You are given an array called nums, and you want to return all the triplets in this array such that they sum to 0. So basically what this is saying is you have to pick three values from this array, from the input array, that add up to 0, and you have to find all potential three values that add to 0, and they must all be different. You can't use 0, 0, and 0. So that is what all of these conditions are saying up here. One possible way to do this is to do the naive solution, which would be you create three indices, I, j, and k, and you would basically increment k until the end, and then you'd increment j once, and then k again to the end, and then so on and so forth. This would be a triply nested loop, which would be big O n cubed time complexity. Pretty horrible, especially if this array is quite long. Not a good way to solve this problem unless you have like a supercomputer or something, or you just don't care about time complexity. So there's a better way to do this, and it involves manipulating the array. So the idea is to take your input array, which I just took the example here. So this is the example. Yellow numbers are the indices, and I sort this array. So now I've got the smaller values on the left and increasing to the larger values on the right. And I still have I, j, and k. But what I've done is I've fixed I, and then I've made j and k into our, I guess, moving pointers. So the equation that we're concerned about here is actually this last one, nums I plus nums j plus nums k equals 0. So that means the value at index I plus the value at index j plus value at index k all have to add up to 0. So if we fixed I can move I over to the right-hand side of the equation as I've done down here. So nj plus nk equals negative ni. So actually, oops. You should have a 4 there. It's minus 4 on this side, so it should be minus 4. I mean, you have minus 4 on this side, plus 4. So now it should be positive 4 on this side. So you have j and k need to add to 4. All right, and if you can do that, then you have your triplet ijk. All right, but how do we iterate this array with j and k? Well, j plus k right now is just 1. So 1 is not equal to 4, so it's not a triplet. Well, what is 1 then? 1 is less than 4, right? So if we want to make our value bigger, what are we going to do? I'll let you think there for a second about it. Should we decrement k, or should we increment j if we wanted to make our value bigger? Well, it makes sense to increment j, wouldn't it? That would get our value to be larger. So that's what this conditional does here. If nj plus nk is less than negative ni, so if minus 1 plus 2, which is equal to 1, if 1 is less than 4, which it is, we increment j. So now we're going to move j up 1. And then we're going to recompute. And it's going to be the same. So we're going to do the same thing. And it's going to be the same. Sorry, it's not going to be the same, but same conditional will apply. It's not going to equal 4. And we're going to keep going. We got 2, and it looks like we're not able to form a triplet. And so we keep doing this. We'll increment I. And then we'll redo these values. And then we will keep moving we'll keep moving j and k, sorry, until eventually we've exhausted all of our potential i's. In this case, until j is less than k, while j is less than k, this loop will terminate at that point. So once j becomes equal to k, which will eventually be at the end. And yeah, so if you do that, of course, at every, you have 3 checks that you're doing at each of these iterations. You're checking, if it's confusing because I have nj plus nk, but let's just think of it as j and k. If we have j plus k less than I, then we increment j. Otherwise, we decrement k. So we move k backwards. And then we finally check if this equation actually matches up. And if it does, we have a triplet. So all we have to do is do that, use 2 pointers to, and the fact that this array is sorted to come up with our solution. And so that's what I've coded right here. So I sort the array, pre-compute the length. I go through my I values. I instantiate j and k, and then I exactly do these same conditionals that I wrote out here in pseudocode. And I add the triplets, which I keep in a set, and then I just return a list because I want a list. And I return my result. And that's our solution. So let's submit this. Judging. Watch out. We're being judged. And accepted. All right. There you go. That's the 3-sum problem.